Our next speaker is Dr. John Kraus from Ohio State. Now, Dr. Kraus cannot be with us in person today. However, because of the marvels of technology, we have Dr. Kraus nonetheless to speak to us by way of video recording. After the video presentation, we will call Dr. Kraus and he will be available on a speakerphone to answer questions on his video recording. I certainly don't need to remind you of the accomplishments of Dr. Kraus. He's one of the pioneers, again, in radio astronomy. One of the books used by many radio astronomy students was written by Dr.
Grote Reber first became known to me through his Wheaton neighbor, Bill Conklin. Bill was a radio amateur, W9 FM. So was Grote, W9 GFZ. And so was I, W8 JK. By day, Bill worked for an investment firm in Chicago. By night, and while on the commuter train, Bill was an editor of Radio, an amateur magazine published in California. In 1937, I published several articles in Radio on a new type of antenna, now known as the W8JK beam, which caused a sensation in amateur radio circles. Bill, as editor, and I, as the author, became well acquainted, and he kept me informed about Grote's activities. For example, according to Bill, Grote came to his house one Saturday and asked if Bill could come over and help him. When Bill arrived at Grote's yard, he found many piles of neatly stacked wooden timbers, all drilled, painted, and numbered, alongside some concrete piers. Bill helped Grote place the timbers, which Grote bolted together, and within a few hours, the framework for Grote's big dish went up without a hitch. This sequence typifies Grote. Everything he does is planned with meticulous care. He designs and builds most or all of his apparatus himself. But he doesn't stop there. He goes on and makes his own observations, plots and interprets his data, and relates his results to theory. In a word, Grote Reber conducts all aspects of his research himself. He's a one-man, self-supported scientific laboratory, a veritable one-man Bell Labs. For the most part, Grote has not been dependent on any institution, foundation, or school. And, as Grote puts it, there have been no self-appointed pontiffs looking over my shoulder giving bad advice. From his amateur station, Grote had communicated with amateurs in more than 60 countries on all continents, and he looked for more distant conquests. Would it be possible, he wondered, to beam a pulse of radio waves to the moon and receive an echo? Perhaps he could. But for one thing, he would need an antenna with high gain, namely a big dish, which he proceeded to build. He installed his transmitting receiving system. We would now call it a radar, and made a few unsuccessful attempts. Further calculations convinced him that he needed more power than the 1 kilowatt to which U.S. amateurs are limited. In this moon bounce experiment, Grote Reber anticipated by a dozen years Jack DeWitt's successful moon bounce with much more powerful equipment. But Grote had read Carl Jansky's articles in the proceedings of the Institute of Radio Engineers about radio waves from our galaxy. So, why not use his big dish to explore the cosmos? At that time, the most likely explanation of celestial radio radiation was that it was of thermal origin, which should be stronger at shorter wavelengths. So on this assumption, Grote designed and built his first cosmic static receiver to operate at 9 centimeters, which was the shortest wavelength it was possible to use at that time. To build this receiver was a feat of electronic engineering requiring much experimental work and development. But by the spring of 1938, Grote's entire system, antenna, receiver, and indicator were in working order, and he began systematic observations of the sky, but detected nothing. At 9 centimeters, thermal radiation should be 26,000 times stronger than at Jansky's wavelength of 14.6 meters, and Grote Reber's equipment should have easily observed it. From this negative result, Reber drew an important conclusion. The radiation from our galaxy is not thermal, and the science of astronomy had taken a first step. Grote decided to try a longer wavelength, 33 centimeters. It was not merely a matter of retuning the 9 centimeter receiver. He had to design and build an almost entirely new receiver. This Grote had working by the autumn of 1938, but again, results were negative. So, once again, he set about constructing a receiver for the still longer wavelength of 1.9 meters. At this wavelength, he found that the ignition systems of passing automobiles produced a severe interfering static or popping noise. But late at night, this subsided, and by April 1939, Grote obtained strong indications of cosmic static from the center of the Milky Way. Pointing his antenna further north, he found that the cosmic static became weaker, confirming Jansky's findings in a general way. All this took place while Grote worked by day designing receivers at a nearby radio factory. After supper, he slept until midnight. Then, until he left for work the next morning, he sat in his basement beside his receiver and recorded the output meter readings at 1-minute intervals, 60 times an hour. On weekends, he had the opportunity to record data at other times, but during the day, the automobile ignition noise prevented him from making good observations. During the summer of 1939, Grote pointed his antenna at many other celestial objects, but found nothing beside the Milky Way radiation. Encouraged by his detection of galactic radiation, Grote Reber next made improvements in his receiver and also purchased an automatic recorder, giving a pen trace on a moving paper chart. No longer would he have to sit up all night recording data. With these changes, he then embarked on the first survey of the radio sky in 1941. Then, for a while, Grote left Wheaton to do research on the protection of ships at the Naval Ordnance Laboratory in Washington, D.C. I was also working at the laboratory on the degaussing of ships, and it was here that I first met Grote. We stayed at the same rooming house, where he told me about his equipment and observations of the Milky Way with a contagious enthusiasm. Grote instilled a desire on my part to build a radio telescope, but my opportunity to do it did not come until 10 years later at The Ohio State University. Grote worked in a group headed by Joseph Keithley. One day, Joe said to me that Grote was the most ingenious and productive person in his group and that he wished he had more like him. I said, I would expect that. Grote, you know, has done some remarkable pioneering observations of cosmic static. Cosmic static? Joe replied, what's that? I explained, but in a wartime setting, noise from our galaxy seemed unimportant compared to urgent matters on planet Earth. After the war, Joe started an instrument company in Cleveland specializing in instruments for measuring very small currents and voltages. It has not become as famous or big as Hewlett-Packard, but his company is well known and highly respected. Once every week or two, some of the laboratory people went bowling. I don't recall if Grote went with us, but I should mention that the best bowler in the group was John Bardeen, who subsequently received not one, but 2 Nobel Prizes. One for his definitive theory of superconductivity. When Grote's work at the laboratory ended, he returned to his old job in Illinois, but I stayed on at the lab. Back in Wheaton, Grote undertook a more complete survey of the sky. This was in 1943. He also detected very strong radio waves from the sun. Although European radars had detected solar emission at about this time, the fact was not announced until after the war. From his survey, Grote produced the first maps of the radio sky. They showed clearly the concentration of radiation along the plane of the Milky Way, the strongest radiation coming from the center of our galaxy in Sagittarius, with other less strong maxima or hotspots in Cygnus and Cassiopeia, a precursor observation to the later discovery of the strong discrete sources in Cygnus and Cassiopeia. Although Jansky's merry-go-round antenna was physically larger than Reber's, the Wheaton antenna operated at a much shorter wavelength, giving Reber better resolution. Thus, the beam width of Jansky's antenna was about 30 degrees, whereas Reber's was about 12. Later, when Reber went successfully to a wavelength of 62 centimeters, he sharpened his beam to about 4 degrees. Grote Reber published his results in the Proceedings of the Institute of Radio Engineers and in other scientific journals. His first proceedings paper on cosmic static was submitted September 1939 and appeared in the February 1940 issue. Grote also sent a cosmic static paper to the Astrophysical Journal. And in my book, Radio Astronomy, I tell a story about it. It was the first time an article reporting cosmic radio observations had been submitted to an astronomical journal, and most persons were either skeptical or puzzled about the results. The Astronomical Journal was and is a refereed journal. That is, manuscripts submitted to it are sent to anonymous experts for their appraisal. Accordingly, Dr. Otto Struve, the journal editor, sent Reber's manuscript to a number of referees. Astronomer referees returned the manuscript with the comment that they didn't understand the radio terminology. On the other hand, radio engineer referees returned the manuscript with the comment that they didn't grasp the astronomical implications. So Struve found no reviewer willing to defend the paper or recommend its publication. In desperation, he wrote to the Institute of Radio Engineers to find out what they knew about this man Reber. As Struve related, the Institute reply was short and to the point, stating that Reber was a member of the Institute in good standing and that he paid his dues regularly. Struve was in a quandary. He had ample grounds for rejecting Reber's contribution, but reasoning that a good article rejected would be a greater evil than a poor one accepted, he approved Reber's article for publication, and it appeared in June 1940. World War II progress in Holland had fallen under Nazi occupation, but eventually a copy of the Astrophysical Journal with Reber's article reached the observatory in Leiden. In reading the article, Jan Oort, observatory director, was quick to perceive that the cosmic radiation Reber and Jansky had reported must be a continuum extending over a broad spectrum. Further, he reflected that some monochromatic line radiation, if it existed, would result in significant advances. He referred this matter to Henrik van der Hulst, a young astronomer at Leiden, who considered various mechanisms for producing line radiation. In 1944, at a colloquium in Leiden, van der Hulst reported that the 21-centimeter ground state transition of neutral hydrogen in interstellar space was a possible source. But the low probability of the transition and lack of knowledge of the hydrogen density in space made it uncertain whether the line could be detected. However, 7 years later, Harold Ewan and Edward Purcell at Harvard University detected the line, and soon others did also. Observations of the 21-centimeter hydrogen line have been of immense value and constitute one of the most important phases of radio astronomy. In retrospect, Rebers Paper, which might not have been published at all, turned out to be one of the classics and an important catalyst in the birth of monochromatic radio astronomy. The Astronomical Journal tale illustrates a basic problem of doing research that bridges disciplines. Most astronomers were either skeptical of Reber's results or they were disinterested. Some stated that although Reber's measurements might be valid, he should leave any theoretical interpretation to real astronomers. And on the other hand, most engineers took little or no note of Reber's work. Grote relates that after conducting a talk on his observations of radio emission from our galaxy to a group of radio engineers, he was asked only one question: what voltage did you use on the filaments of your amplifier tubes? Reber was in between two groups speaking different languages. Reber fills an important niche in the history of science. First, he was the first to follow up in a significant way on Jansky's discovery. Second, he laid the foundation of the new science of radio astronomy. Whereas Jansky expressed results in volts per meter, Reber related his results to the cosmos in terms of flux densities and brightness. Third, he recognized the significance of a radio telescope as a radiometer, in which the radiation resistance of the telescope antenna measures the equivalent temperature of distant regions of space lying within the antenna response pattern. Fourth, his measurements demonstrated that the galactic radiation is non-thermal. Fifth, he produced the first maps of the radio sky. According to George Southworth, famous for his waveguide research at the Bell Labs, it was not until after Grote literally drew them a picture of the radio sky that astronomers began to take notice. 6, for a decade, Grote Reber alone nurtured and developed the new science of radio astronomy, doing it in his free time at home while working during the day designing receivers at a radio factory. 7, his backyard dish is the prototype of the modern radio telescope. It's indeed fortunate that in 1937, Wheaton had no ordinance against backyard dishes. Reber was the right man doing the right thing in the right place at the right time. 8, and while most radio astronomers have moved to shorter wavelengths, Grote Reber has pioneered in long-wave radio astronomy. First, in work atop Mount Haleakala on the island of Maui, Hawaii, later in Tasmania, and now in Ottawa. Whereas birds migrate between hemispheres with the sun, Grote migrates opposite to the sun. In his observations at 144 meters through occasional holes in the ionosphere, he has found a reversal in the appearance of the radio sky, with the galactic poles being bright and the center of the galaxy dim. To accomplish this work, Grote has had to do extensive research on the Earth's ionosphere and when and where he could find holes to observe the cosmos at long wavelengths. Grote's 144-meter wavelength antenna, which he designed and built in Tasmania, covers an area of over 1 square kilometer and is physically one of the world's largest radio telescopes. And while in Tasmania, Grote has also built a north-facing solar house. For Northern Hemisphere long wavelength observations, Grote is now operating a counterpart of his Tasmanian array here at Ottawa, converting an abandoned military antenna array into a radio astronomical telescope, a Swords into Celestial Plowshares project. Did you know that there is a Rebers Hubble Connection? As I relate in my book, Big Ear, around 1900, the Hubble family lived in Wheaton, Illinois. As his 7th and 8th grade teacher, young Edwin Hubble had a Miss Harriet Grote, who later married Schuyler Reber and bore Grote Reber as her first son. She often commented to Grote that young Edwin Hubble stood out from the other students in his class and that she felt he would go far. In later years, when Hubble's fame was spreading, she took special pride in his accomplishments and that she had been one of his teachers. In addition to radio astronomy, Grote Reber has many other interests. For some years, especially while a guest radio astronomer at The Ohio State University, in the early 1970s, he did cosmic ray research. He is shown here sitting at his desk at the Radio Observatory at Ohio State. While atop Haleakala, he observed atmospheric pressure variations, publishing his results in a meteorological magazine. Grote is a keen observer of nature and has made observations on a number of plants, finding that if you unwind a twining bean plant and wind it back in a reverse sense, the ratio of bean to shuck weight is increased. The bean plant here, the vine grows this way, you mechanically unwind it, wind it back the other way. And he got more bean to shuck weight. Although many textbooks state that a plant which winds as a right-handed helix in the northern hemisphere winds as a left-handed helix in the southern hemisphere, Grote found that his plants wound the same way in both hemispheres. Grote has published a series of articles on his botanical work, and while in Australia, visited prominent botanists to discuss his findings. While there, the new big radio telescope at Parkes held a dedication ceremony, which Grote naturally attended. Many Australian dignitaries and scientists from many disciplines were invited. One of these was a famous botanist Grote had visited previously, who came over to him and remarked, "We botanists really don't belong here, do we?" Let me list a few titles of Grote's diverse publications. Cosmic Static, Reversed Bean Vines, Radio Interferometry at 3 kilometers above the Pacific Ocean, Radio Astronomy in Hawaii, Suppressed Side Lobe Antenna of 32 elements, Cosmic Static at 144 meters wavelength, Atmospheric Pressure atop Haleakala, Spread F over Washington, Spread F over Washington. Fine structure of solar radio transients between the atmospherics, solar activity and Spread F over Hawaii, worldwide Spread F. Unusual variation in Phaseolus vulgaris. Phaseolus vulgaris is not a southern hemisphere constellation, it's a bean plant. And vulgaris simply means that it's the common variety. Cosmic ray astronomy, atmospheric pressure oscillations in Tasmania, ground-based astronomy, hectometer cosmic static, intergalactic plasma, and many more. So, Grote is a botanist, an engineer, an astronomer, a meteorologist, and an explorer of the cosmos in its broadest sense. In 1962, Grote delivered the Russell Lecture to the American Astronomical Society, and he also received the Bruce Medal of the Astronomical Society of the Pacific. The following year, he received the Elliott Cresson Medal from the Franklin Institute. A young student once asked Grotes Advice about what to do to discover something really new. And Grote said, "Pick a field about which very little is known and specialize in it. But don't accept all current theories as absolute fact. If everyone else is looking down, look up or in some other direction, and you may be surprised at what you will find." Put another way, what Grote was saying was, don't go with the buffalo herd. But I might add that if you do find something, watch out, because the herd may turn and trample you. I have known Grote now for almost a half-century. I was his sponsor for an honorary doctor's degree he received from the Ohio State University in 1962. I'm shown here congratulating him on that occasion in front of a cornfield at my farm. His citation reads in part, and I quote, "Grote Reber is America's pioneer radio astronomer who turned to the heavens and opened an unseen universe to the exploration of man. Today, Grote Reber is acclaimed by the radio and astronomical scientific communities as the foremost pioneer in this new field and as a productive research scholar whose leadership continues. This university one of the first in the United States to undertake work in radio astronomy, honors the founder of this science and becomes the first university to formally recognize Grote Reber's brilliant contributions to knowledge. End of quotation. These statements are even truer today than they were 25 years ago in 1962. Grote, you are a living legend. You are my friend and fellow explorer of the cosmos, and it is my privilege to participate today in your 76th birthday celebration here in Ottawa. Congratulations and many happy returns.